welcome to our next unit. It's going to be on random variables. Going to correspond to chapter 6 in your textbook. So the first section of this, we're going to be talking about continuous and discrete random variables. And these are the things we're going to learn. Going to apply the concepts of discrete random variables, calculate and interpret the mean, expected value of a discrete random variable, calculate and interpret being the important part, the standard deviation of a discrete random variable, and then describe continuous random variables. This sounds scary. It's not. It's just a repeat largely of the normal reinforcement of normal distributions. So, what is a random variable? Well, a probability model describes the possible outcomes of a chance process and the likelihood that those outcomes will occur. A numerical variable that describes the outcomes of a chance process is a random variable. A random variable takes numerical values that describe the outcomes of some chance process, blah, blah, blah. Read it, write it, do whatever it is you're going to do with it. If I go too fast, pause the video. So look at this. Consider tossing a fair coin. Define x as the number of heads obtained. So x is now a random variable. And if we flip the coin 3 times, we could get 0 heads, we could get 1 head, we could get 2 heads, or we could get 3 heads. And here is the sample space, right, with 1, 2, 3, 4, 5, 6, 7, 8 outcomes. Now those outcomes are not equally likely. So there is a 1/8 chance. 1/8 chance we'll get an outcome of 0. There's 3/8 chance I'll get an outcome of 1 head. There's a 3/8 chance I'll get an outcome of 2 heads, and there's a 1/8 outcome I'll get an 1/8 chance I'll get an outcome of 3 heads. And here is the histogram of that data. And remember, if I was going to ask you to describe that distribution, you would describe it with SUX. And remember that SUX stands for shape, unusual values, including outliers, but also unusual shapes, unusual values, or unusual, let's call it unusual features. And then center and spread. Center and spread. And so we would say the center of this graph is 1.5. Isn't that the center? So the shape is unimodal and symmetric. Now we do not know how to find the standard deviation, which would be our measure of spread, but we will learn that today. So a discrete random variable, as opposed to a continuous random variable. If you can find a way to list all the possible outcomes for a random variable and assign probabilities to each one, we have a discrete random variable. All right. Coming back to this one, if we flip the coin, we can't get 1.5 heads. We can't get 2.5 heads. We can either get 1 head, 2 heads, right? It's discrete. There is a set number of outcomes that are possible. And so that's a discrete random variable. All right, so some rules about discrete random variables. The probability of every outcome is between 0 and 1, right? Because that's the rules of probability. The sum of all probabilities has to be 1. It's another rule of probabilities. And this last part looks a little confusing. Define the probability of any event, add the probabilities p sub I of each x sub I that makes up the event. I know this x sub I and p sub I freaks us out, but remember, your first value is x sub 1, so the probability of it occurring is p sub 1. The second event is x sub 2, so the probability of it occurring is p sub 2. And so for all of those, then it's x sub I goes with p sub I, and the i's just go up from 1 to n, however many outcomes are possible. All right. So how do we find the mean? Let's say the last one was easy. It looked clearly like 1.5. But how do the how do we do that? So what we do is that all the outcomes are not equally likely. And so we do what's known as a weighted average. And you may have done this before. If you haven't, I can do an example of it in class. Just ask me. Say, do an example of a weighted average. So the mean of any discrete random variable is the average of all possible outcomes, with each outcome weighted by its probability. So what does that mean? Well, that means this. And this is the formula that you will see for this. And I'll unpack this for you. But the last part of this, right, mu sub x, which is the average of x, is the sum of every single number times its probability. And this formula is on the formula sheet. So it'll be on the sideboard when we talk about it next class. You will also see this, e sub x, because the mean of a random variable is also the expected value. And what does expected value mean? Well, remember, probability in the law of large numbers says that any outcome is will get the experimental probability if we run it many times. So the expected value is, if we ran infinite number of things, that would be the average per event. I will demonstrate how this unpacks and what we mean by this right now. So this is, someone sat down and looked at all the goals scored in all NHL games in some year, and they looked it up, and they said, all right, what is the most goals scored? And there's a very few games that had 9 goals scored, and there's a few games where there was 0 goals scored, and they found over the entire season what was the probability of each. So how would we find the mean? So once again, mean is defined as, and you'll see this is the formula on the formula sheet, e sub x equals mu sub x equals sigma x sub I p sub I. So e sub x equals, the first value is 0, and the probability of occurring is 0.061. The second value is 1, and the probability of it occurring is 0.154. Excuse the announcement.
Mr. Lee, you're needed in the main office. Jade Stevens, please meet your ride out front. Jaden Stevens, please meet your ride out front. Your ride is outside at this time. Thank you.
Ooh, someone's got a ride. Plus 3 times 0.229 plus 4 times 1.73 plus 5 times 0.094 plus 6 times 0.041 plus 7 times 0.015 plus 8 times 0.004 plus 9 times 0.001. Right, so it's the sum, right, which is why we're adding all the time, of each x sub I times its p sub I. And so if you plug all that into your calculator, which you should pause and do and make sure we get the same answer, we get a value of 2.851. But if you remember, in the thing, we said we learned to find this and interpret it. So in the example, this was the, goals per game for some NHL season. So the interpretation of this is if we went to any game at random, if we picked a game at random, we would expect there to be 2.851 goals scored, which is a little hard to wrap our heads around, because if you went to an NHL game, you can't score 2.851 goals. You could score 2 goals and you could score 3 goals. And so what this is really telling us is that we're most likely to either see 2 or 3 goals, and we're slightly more likely to see 3 than 2. But we could also see 4, and we could also see 1. But that's the average goals per game. That's the expected value. And we're going to play a lot more with expected value in our next class, because that's expected value is kind of how everything runs in Vegas. When we start looking at different casino games, the expected value will be what you can expect to win or lose on any particular bet. So, and there we go. So, there's the same thing in the interpretation. There's a textbook interpretation if that's what you should put on your AP exam. Notice that they didn't write out the whole thing. You can do this. You don't have to write it all out. If you just start showing, you just did the first 2 and the last one and put ... in between, that'd be fine. You don't have to write the whole thing out. You can do the majority of work in your calculator. You don't have to write it all down on the AP exam. As long as you were to show that you were properly applying the formula, you'd be fine. So then how do we find the standard deviation? So, the interruptions are going to make me nuts.
Mr. Martinez, if you're still in the building, please call the main office. Mr. Martinez, if you're still in the building, please call the main office.
So, here it's to find the standard deviation. What we do is we use this formula to find the variance. And remember, by definition, standard deviation is the square root of the variance. So, remember the symbol for variance is sigma squared, which is right here. And so and the symbol for standard deviation is sigma. So the square root of the variance will be the standard deviation. So what we have to do is for each one, it's like before, but instead of multiplying it by x sub I, we're going to multiply it by x sub I minus the mean, and then multiply it by p sub I. So let's go through this hockey example again. Once again, this is also this formula here. Oh, and we square it, is also on the formula sheet. On your SOL, it says the variance of a random variable x. So, see this. Each value minus the average, and then we're going to square it so that they're all positive. Then we're going to multiply it by the probability, and then we will add them all up. So, we had already calculated that mu sub x is 2.851. So, the variance of x will be (0 minus 2.851), and this is the first value, right? And this is the mean, squared times the probability of that occurring, plus the second value minus the mean squared times the probability of the second value occurring. And this is where it really pays off to do the plus ... plus 9 minus 2.851 squared times the probability of that occurring. And you add all that up, what you will get is about that. I'm writing out plenty of decimal places. So that's the variability. So remember that the square root of variable is the standard deviation. So then I would have to take the square root of that, the variance, and I would get, oops, square root 1.6324. I'm going way too many decimal places. So that is the standard deviation. Then I need to interpret it. So in the long run, we would expect the goals in a game to remember average. So remember standard deviation is not too average. 1.6324 goals. I can't spell goals. That's not good. Goals above or below 2.851, which was the expected value. Remember, standard deviation is how far we're going to be away from the average on bunny ears average. Remember our definition of standard deviation. Continuous random variables are easy. A continuous random variable is where it's continuous, and so the only way to do it is to look at the probability of being between two values. So you can read this down. The key is that a probability is going to be described by a density curve. And so if they ever ask you any questions about this on the AP exam, it's going to be a density curve you already know. And right now, the only density curve we really know much about is the normal curve. And so what you will tend to see is that those problems will end up being normal probability problems. So pause this, write this down, but we will do examples of this tomorrow in class. And that's it for today's video. I know it was a lot to digest. It's kind of mathy, but don't worry, we'll practice it some in class. See everybody next class.